lot of patent data. All right.
Yes,
You
sir.
wanted to go
I'm
back?
going to give you the rights again,
Okay.
and you may please share your screen and continue.
All right. So, okay. Let me go
If
back.
you can just very briefly start, because I don't know which part of your session it has got automatically paused. So if you can just go through from your first, second slide, just keep skimming through the slide till where you had reached.
I think, whatever I talked till now, it is all I'm just, summarizing and repeating. There is nothing great. So,
Perfect. Okay.
yeah, so there is nothing, so now benefits of now I am a strong believer that the boiler tuning, we talked so many things. We talked about flexibilization, we talked about air fuel ratio control, we talked about efficiency, we talked about unburned carbon. I think it all revolves around the boiler tuning. And if Mr. Chandrasekhar is there, probably he can comment on it. So boiler tuning, somehow I have seen it is like our car. We buy a car, but we hardly go for tuning. We keep on filling the petrol or diesel and keep on running. So boiler tuning is important. And here I have shown the benefits of boiler tuning, minimizing the unburned fuel, reduced tube failures, improve combustion balance, minimize energy losses, scale down fouling, reduce slagging, diminish corrosion, and of course SO2, CO2, and NOx emission. So boiler tuning is important. It is related to the O&M day-to-day performance, and I think we must do boiler tuning twice in a year. So these are the benefits. I already shown you the picture in the photograph. This is written in the text, same thing. But boiler tuning is important, which somehow we are having no habit to do it on regular basis. Now, everybody talked about a retrofit, a renovation and modernization. Uh, with my experience, I wanted to share when the turbine is retrofitted and it is ready for highest level of performance, the boiler should be capable of doing and supporting that with the required steam, temperature, and pressure. So, in our experience, what we did, and many state boards and many customer followed, that they had done the reheater modification also. I mean, just to share, because many a times it is missed, and many a times it creates confusion because the RNM package of turbine generally is handled by a turbine manufacturer, and then turbine manufacturer is mostly interested in turbine 3D blades and all those, but he is not bothered about the reheater modification. So with many cases, what we did, we try to educate customer and tell them that reheater modification is also important. And I'm sure our colleagues from TC and other power companies will agree to it and see in their future RNM reheater is given a due respect. Turbine retrofit, it is all generic photographs, how it is done. Just seeing is believing. So just to give you a feel, generator upgrade, there are generators which has a lot of margin, and if it can generate more megawatt, it is not bad. As I shared with you about ENF station, it was increased 110 megawatt to 121 megawatt. So a lot of margins are there, and this is the time to optimize, to extract the maximum available capacity of the equipment. Now, A2CS upgrade, we already know that FGDs and SCR, ESP, ZLD, all those things are also important to reduce the emissions and effluent and the toxic things which is affecting our operators and surroundings, and it is causing a bad health. So this is important. Benefit of retrofit, there is a case, Bukai Vanagbori, it is taken from the public domain, and you see the difference before RNM and after RNM. So it is evident and clear that RNM has to happen. RNM is a tough task. I know many utilities are not very keen because it requires time, it requires a lot of patience, it requires sharing of a lot of information, and probably this is one of the reasons RNM has not become very, very popular in this country. Even if RNM happened, it took a lot of time. I mean, it took years and people who started the RNM procedure, both customer side and the OEM side, they retired, but RNM never took place. So this is the time, since coal-fired power plant is to be kept alive, RNM is important. And I have taken a list of some of the plant which I could find the data. Here it is basically a 75,000 megawatt Chinese fleet in India. Why I took Chinese? Because Chinese are labeled uh, bad for many things, design, so many issues, so many challenges. So what I did, I took the data from the Chinese plant, right from 61.5 megawatt to 660 megawatt, and I tried to do some kind of analysis about their design heat rate and the heat rate improvement which is possible. And during the process, it is just indicative numbers. I mean, these numbers are not the accurate numbers, but very close to accurate. uh, Idea was to tell you that how much coal can be saved if all these plants are done with retrofit, renovation and modernization. And you see yourself, there is a per megawatt 286 ton saving in a year, and huge money which is saved, around 7,634 crore money is going to be saved, right, only from the coal saving itself. So it is not only coal saving, there is a tremendous amount of CO2 emission which is reduced. 1 kg of bituminous coal emits 2.14 kg of CO2. So overall, just to give you a feel that there is a large fleet of 76,000 megawatt. Every power plant is stressed. Efficiency is a big issue in most of the power plant. Heat rate is a big issue. So if those are all corrected, there is a significant amount of cost saving in terms of transportation of coal, SPM, ash, so many things which cannot be quantified, but which can be taken the benefit of. So this is just a calculation about carbon credits, because we all talk about carbon credits. Carbon credit, if you register these projects for the carbon credit benefits, somebody yesterday, Vikas Ranjan was talking about carbon emission and credit and PAT scheme and triple C, E-cert and all those. So there is a huge benefit if you register these projects for carbon credits. You see, in this case itself, it is a 600 megawatt plant. In this case itself, you earn every year around 2,93,009, $2,09 per year, and this is available for next 10 years. So big amount of money can be earned, big amount of benefit can be given to the employees in terms of better health. So this is just to give you a feel that benefit of carbon credits, and carbon credit and carbon market is going to rule this country, and carbon has to be reduced. So return on investment, another case. Here I talked about some payback on RNM, which is around 2 to 3 years. Again, it is very case specific. So just to give you a feel in terms of commercial benefits. Now, heat rate improvement opportunities and challenges, you all know. Challenges are aging staff, no interest, a lot of, and then you have seen in last 30 years, there have not been much attraction for the new engineers to come to the sector. So that is a challenge. Regulatory norm is a challenge. Loose PAT target is a challenge. Failed decertificate scheme is a challenge. Carbon credit are the challenge. Not attractive. Funding issues are the challenge. Limited companies doing it, and the knowledge. And opportunities are, most of the plants are stressed, proven and stressed, sustained R&M projects, good payback, O&M with retrofit technology, faster executions. So these are the benefit. Now, my main topic today to talk about repowering. The idea is how to reduce the carbon and how to use the existing asset. All these coal-based power plants are very heavily designed. Basically, they are over-designed. And once you abandon them, it becomes it goes in the price of scrap, which is not the right approach. So these assets infrastructure can be utilized in many ways. I have gone through the globally, I mean, and I have seen many things happening across the globe. So instead of we looking towards the globe for everything, why not we start doing this activity and using our stranded asset for using them for various purposes. So here I have just tried to put my knowledge about the repowering, what is going on globally. And then these are the information I gathered from public domain, from the media about many activities which is happening on the repowering front. Repowering is all about low carbon, no carbon, using the infrastructure and the asset which is available. Now, there are myths around repowering globally, which the myth is answered here. I will share these. I am not going to read it. It is too, like first point, the first myth is it is too hard to budget a repowering project. It all depends on the willpower. It all depends on your best plan and the engineering abilities and your own ability to sell the outcome of the project. So there is nothing which is cannot be budgeted. Repowering units are not competitive and new unit for plant efficiency. Again, this is a myth. It can be proved wrong. There are a lot of engineering capability in our country. There are great consultants. Repowering will lead to the elimination of power plant job. It is not true. There are projects globally where the coal-based power plant, because definitely power plant closure is going to create a problem. And India is already suffering. The coal sector has suffered a lot in last few years because there have not been much focus on the coal-based power plant. Though government never said that coal power plant will not be there, because we have seen a lot of tenders recently from NTPC and it is getting awarded. So coal power plant are going to remain there. And the fourth myth is the existing equipment won't last. Fifth myth is construction at an existing site is too difficult. So all those things are not very relevant, but these are the thought process of people who thinks about repowering. We can read the answers. I will share the slides to see for posting on the website. Now, oxy-fuel technology, it has been discussed a number of times. It's a proven technology, and I personally feel that oxy-fuel can give a good solution to the zero emission, because we are targeting net zero by 2070. So it is oxy-fuel is not something new for us. It's a matter of taking a challenge and working on it. So here I have tried to show you a pictorial view how air separation happens from the air. Oxygen goes for the combustion, coal is added, and then there are FGT, flue gas treatment, and then this is how the plant works. So oxy-fuel is one technology which definitely we need to opt for. It has been a proven technology, slightly costly, but I believe if the government subsidy is available, it can be made feasible. Ammonia co-firing, a lot of discussion happening now. Ammonia can be generated from the hydrogen, and ammonia is being co-fired in the same coal boiler. IHI has taken the lead, and in India also, I believe I was reading somewhere, Adani has tied up with them. So green ammonia firing is all about reducing the CO2 and using the same boiler with little modification. So this is the ammonia co-firing with the pulverized coal to reduce the NOx emission and the CO2 emission and SOx emission. Now replacing a coal-fired power plant with a combined heat and power gas plant. This is a project which is happening in China. And yesterday, after listening to Ranjan, I found that China is much more aggressive than us on various measures to reduce the CO2 emission, though their targets are 2050. And they are 29% emitter of carbon in the world, and probably their generating capacity must be 5 times than what we have in India. So, so this is the project which is being done for them by GE. So we can have the similar project, and this is going to be beneficial. It is going to be neutralizing carbon and carbon reduction. Even hydrogen can be burned there. Now, in the US, more than 100 coal-fired power plants have been replaced, are converted into natural gas, since 2021. Somehow, India gas story is weak, so we cannot talk much about it. But there are, turbines available which can fire where 50% hydrogen and 50% natural gas can be fired. So there are ways and means to reduce the carbon emission, to use the available infrastructure and the asset. IGCC, Mr. Chandrasekhar also talked about it yesterday and today as well. IGCC, my personal take is not very commercially viable for power generation. But then there are companies like Jindal and all, they are running IGCC plant in India. And I remember there were many projects which started with many collaborations. But IGCC, sometimes I feel that it is good for some kind of chemical process and all. So IGCC is another technology. It has not been a very big success in India because of our high ash content coal. So this is one way of another way of decarbonizing. Clean coal technology, as we all know, clean coal technology is another. The term clean coal has been popularized by coal industry, electric industry, and policymaker. It refers to the hopeful notion that technology will enable power plant to burn out, release far less pollution, which stands for carbon capture and storage. Carbon capture and storage is definitely a talk of the town today. A lot can be done in India. Somehow we are again looking at westwards, and there are some projects which is going on in India. There is a need for IITs and local companies to work on it and develop our own clean coal technology. So clean coal technology is another area where we can think of adding some of our infrastructure and asset to have our own indigenous make in India technology. Repowering coal to the natural gas by 100% hydrogen by 2025. Utah is the place in US which has replaced 1.8 gigawatt worth coal-fired power plant, and now they are putting up a hydrogen plant there, and they are putting up a gas turbine to burn initially 50-50 with natural gas and hydrogen, and then slowly they are writing that by 2045 they switch over to 100% hydrogen. Again, depends on the support from OEM, and but it is a very good project. It is a very futuristic project. Repowering coal plants as a pump thermal energy storage. This is another area where a lot of work is happening in India also. That is why in one of my earlier presentation I said if the flexibilization is the issue, why not use that power to have the pump thermal energy storage at the time when when the plant is generating, and then we use it when there is power is expensive. Because somebody talked about Mr. Chandrasekhar talked about power going out of the PPA regime and all. I think which is very unavoidable. I mean, this has to happen. So time will come because the plant has to survive, plant has to make money, and then there should be a tariff depending on it should be opportunity based costing. So in that time, the energy arbitrage kind of approach help to use these stored energy. So this is about the same technology we talked about, impact on high heat rate, then impact on high heat rate for storage. I will share, you can read it more in detail. These are all good information. Malta is the company which is working on this project. It's a thermal storage project. This is a 100 megawatt project, and this can give you power for 10 hours. India, at the most, what we are talking about, a lithium ion battery, and battery is a hazard. Battery recycling is another issue, and I'm not very sure. I see a lot of tenders coming out with huge capacity, 10 megawatt hour and all those. So I personally feel that we have to have a long duration, sustainable energy storage system. Lithium ion performance is yet to be seen, though there are a lot of discussion, a lot of betting. We talk about tariff and so many things. So Malta is one company which is developing, and Malta is having a lot of Indians working with them. So this kind of project can work in India also. It needs the large business houses support, government support, and Ministry of Power support. Replacing coal-fired boiler existing coal plant with carbon-free small modular reactor. Now, another concept I see many companies are working on it, including the company I used to work for, Doosan Power. They have developed SMRs, and these are all factory fabricated SMRs available up to 300 megawatt. And these can utilize almost 50% of the asset and the structure of the coal-based power plant. So this is another area. Nuclear is always a politics. Depends on the government policies. But then the small modular reactor technology is one of the futuristic technology towards decarbonization. This is a pictorial view of one of the plant where SMR is implemented. You see the size of coal-fired power plant at the top, and then the bottom you have a SMR technology power plant of the same capacity. There are system benefits, low-cost system, have fuel diversity, long-term price stability, and then so on and so forth. There are so many points, you can read it. So this is about SMR technology. Carbon neutral thermal power generation using ammonia. We already discussed. And you see how ammonia is fired in the same burner. Maybe the burner is different, but then ammonia firing, and a lot of ammonia is being generated in India also now with the same hydrogen plant. So there is the option of carbon neutral thermal power generation using ammonia. This is another view of IHI is taking the lead, IHI Japan, and there are some projects which is ongoing. We can have a similar project in India also, and probably we can succeed much faster. So here again, there are opportunities and challenge. I will not read out all the points. These are all very generic points. I put a poll in the LinkedIn and about repowering, and you see the result. People have given almost equal weightage to thermal energy storage, modular nuclear reactor SMR, combined cycle plant 29%, subcritical to supercritical. So combined cycle power plant is a question mark here in India. But then again, there are customers and there are people who are interested in it. So this is about the poll which I posted on LinkedIn. This is the scenario I wanted to show, because everything we talk in terms of 2030. 2030 is going to have around 817 gigawatt capacity installed, out of which coal is going to be 266. This is the projection. But if you see the million unit generated, the coal again is going to generate 54% of the total units, which is used by us for various purpose. So this is about the plan for 2030. Coal is going to remain. All other wind, biomass, nuclear have to grow. A lot of capacity is being added. So this is about our 2030 plan, and this is taken from the CEA report. So this is all from my side. Views expressed in presentation is all personal of author and only for discussion. Data, photograph, courtesy, various websites and public domain. So thank you so much for your time, and I'm available for any question if you have. Thank you so much.
Thank you, Mr. Verma, for that very much in detail presentation. And it's always a pleasure to hear you when you put your views and your perspectives so open in front of us. I would request the attendees, if you all have any questions for Mr. Verma, you all could key it into the Q&A box.